Good afternoon, guys. Just making this video to get you guys caught up on 4I and 4J since I'm not going to be here this afternoon. So what we're going to do is there's some instructions here on the top of 4I on angle bisectors. I'm going to go ahead and go in GeoGebra and sort of draw these up. Um, so I'm going to come here. I'm going to do a segment right here. Make an angle like this. All right, and you can do that. You can follow along if you want to. If you want to just watch, you can just watch. Okay. So here's what we got. So we have a segment right here, or an angle, I should say. And I'm gonna do the angle bisector. So I can hit this angle bisector tool down here. Click the three vertices of the angle, A to B to C, and voila! This line that cuts through there is the angle bisector of that line. Okay. Kind of like with perpendicular bisectors. What's cool is that I open the angle up, bisector moves with it, so it's very interactive. Okay. So next thing we're going to do is I'm going to take a point. I'm going to place a point on this perpendicular bisector right here, be point D. Okay. And now what we're going to do is we're going to find the distance from D to this thing and D to this thing. Okay. So what I'm going to do is I'm going to do a perpendicular line from point D through there, and another perpendicular line from point D through there. All right. I'm going to put a point right there, E, F. Okay. So this line here, again, coming up and down is my angle bisector. I just did these perpendicular lines here because these are going to delineate the distance from point D to each of the sides that are on our angle. Okay. And as we see, the distance from D to point E is the same as the distance from D to point F. Okay. And that's not a mistake. Okay. So point D is on the angle bisector. And as I move that angle bisector, those points kind of move with it. And we see that the distance from point D to F is going to be the same as the distance from point D to E. Okay? So D to F is going to have the same distance as D to E. All right? Now, again, kind of like what we did with perpendicular bisectors, we see here that we have two triangles. All right? There's an orange triangle right here. We have this purple triangle right here. Okay? So we know we have an angle bisector up top. So we know that this angle here is congruent to that angle right there. All right? And we know that we have a 90-degree angle here and a 90-degree angle there. All right? And we know that these two triangles share that side right there. So these two triangles are congruent by AAS. And because of that, that's what's going to make, that side. Let me go with a different color there. Go red. That's what's going to make DF congruent to DE. Okay? Because when I do the angle bisector through this angle right here, it's going to make two triangles that are congruent. And so by CPCTC, this is going to be congruent to that. Okay? So if I go back to my four notes right here, the angle bisector theorem states that if a point is on the bisector of an angle, that point is going to be equidistant to the sides of that angle. Okay? So, again, I have an angle here. All right? I bisect the angle. Okay, I'm cutting the angle in half. So if I put a point randomly here, all right, and I do the distance from there to there and the distance from there to there, that distance is going to be the same as that distance, wherever I have a point on the angle bisector, okay? And the point where they meet, that is called the incenter. All right. Oh, I kind of got ahead of myself a little bit. Sorry. So we're going to construct a triangle and do the angle bisectors of the three angles. So what do we see? So if we go back to GeoGebra here, I'm sorry for getting ahead of myself. Let me go back. Let me clear my screen. All right. So we'll do a triangle here in GeoGebra. All right. I'm do the angle bisector of all three sides. So where is it? 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 Here it is. Okay, so there's the angle bisector there. Okay. So what's going to happen is if I put a point on this angle bisector, point D, all right, the distance from D to here, all right, is going to be the same as the distance from D to that line. All right. Again, as I move point D, okay, the distance from D to line A is the same as the distance from D to line C. All right. Now, when we do the other angle bisectors, so these angle bisectors also are going to meet in one spot. Okay. All the angle bisectors are going to meet in one spot. All right. And that spot is what's called the incenter. All right. So we'll go back to our notes. The point where those three angle bisectors meet is called the incenter. Okay. The incenter. All right. And again, they're always going to meet in one spot. All right. If we look at the triangle as we move it here, the three angle bisectors, okay, the things that are cutting the angles in half, all meet at that point. They're always going to meet at one point. So the distance from D to line A, D to line C, D to line B will always be constant no matter what. As I move this thing around, you'll see that the distance from D to all those lines is the same. All right. What's cool is now if we do our circle with this, all right, now we see D, we're going to create a circle that is inside the triangle. Okay. So the angle bisector is going to create that circle that's sort of inside the triangle right there. Okay. Which is kind of cool. So coming back to our notes, the incenter lies on all 3 points of the perpendicular bisector, or the angle bisector, excuse me. Okay, the theorem states that if points on the angle bisector is equidistant to the sides, so the incenter is going to be equidistant to the 3 sides of the triangle. Okay. All right, we kind of just did that circle already. So angle bisectors form the incenter. Okay. Incenter is equidistant from the sides. All right. So in this triangle down here, the blue lines there, and there are the angle bisectors. Okay. These red lines are the distance from the incenter to the sides. And from point P is the center, I could draw a circle right through those 3 points. So PU is 7, PS is equal to 7, and PT is equal to 7. Okay? So in this picture, PU, PS, PT are all equal to each other. Okay? So we can solve that equation out there. So it's the opposite of perpendicular bisectors. Remember, perpendicular bisectors cut the sides in half, and the lines to the angles are equidistant. Okay? Angle bisectors, excuse me, cut the angles in half. Okay, the blue lines are cutting the angles in half, and those red lines are equidistant to the sides. Okay, so that kind of takes care of the last part of 4I. 4J I did with my other class the other day. I want to talk about it just briefly. And I'm also going to attach a Khan Academy video to this thing as well. All right. So I'm going to clear the screen right here. Pause the video if you need to. Go back if you need to. So going to 4J. Altitude is another word for height of a triangle right there. Okay. I know it says mentioned in the 4I notes. It's not. Height is always measured at a 90-degree angle from the base. Whenever I have a line and I want to find the height to the top, I always measure height at a 90-degree angle. Think of when you go to the doctor and they measure your height. They measure at a 90-degree angle to make you stand straight up. Okay. So that's that. I'm gonna go in GeoGebra and show you guys real quick. You don't need to copy those down. I'm just gonna show you the altitudes and what they kind of look like. Okay. So I'm gonna go here. I'm gonna clear my triangle. I'm gonna make a new triangle here. All right. Let's say I make it. I want it to be an acute triangle, maybe something like this. All right. So now I'm gonna do a perpendicular line from B to there, and A to there, and C to there. I'll move this around a little bit so the thing gets more in the middle. All right. I'm gonna make a point here, there, and there. Okay. So what we have is we have this line FC. Okay, this is an altitude. So down here, this is a 90-degree angle, goes through C. This line AE is a 90-degree angle here, goes through point A. This line here has a 90-degree angle, goes through point B. All right, and we don't really need to worry about any of these lines on the outside because these three lines there are the altitudes. And we see that the altitudes are also going to be concurrent to each other. They're going to be in the same spot. And no matter what, the altitudes are going to meet in the same spot. No matter what, inside the triangle, outside the triangle, they're going to be concurrent as well. Okay? So the altitudes of a triangle are concurrent. And I'm going to show you guys why here real quick. Khan Academy has a really good video on it here. But the lowdown is this. So I'm going to draw a line parallel to AB that goes through point C like this. I'm going to draw a line through point A that's parallel to CB, something like that. I'm going to draw another line through B that's parallel to AC. So it looks something like that. Okay. And what's going to happen is this. I didn't draw the altitudes yet. But what's going to happen here is this. If I look at these angles in this triangle right here, all right, angle A is, is this angle right here. Let's say angle B is this pink angle right here. All right, and angle C is this blue angle up here. All right. Now, using our parallel line rules, what we can kind of do is we have some alternate interior angles that we can sort of kind of bring along here. So, using this green angle with this, and this being a transversal, I could pull the green angle down here. Okay, I'm gonna pull the green angle down there. With the pink angle, with this, and this, I could pull that pink angle right there. Okay. Now this green angle down here is corresponding to this green angle here. All right. So this green angle here, I could pull here. All right. This blue angle up here, I could pull down here. And pink, I can pull there, and I can put pink here. I can pull blue there, and blue can go here, and pink is up there, and so green is down there. So what happens is, guys, when I do these parallel lines, I end up with 4 triangles where all the angles are the same, but they also share some sides. You know, this side is there. So all these triangles are going to be congruent to each other, okay? So what's going to happen is this yellow side right here is going to be equal to this side right there, and it's going to be equal to this side right there. All right, and you know, this purple side here is going to be equal to this purple side here. All right, and it's also going to be equal to this purple side right there. All right, and then this orange side here is going to equal that orange side there and that orange side there. So we're going to have 4 triangles that are all congruent to each other, okay? And so what happens is this. I'm going to redraw it kind of out here. All right. So when I'm doing the altitudes in this little triangle.
Okay, seniors, make your last stop and get back to class.
So from here,
enjoyed your senior trick-or-treating.
All right, from this point here.
Happy Halloween.
Thanks for interrupting. Okay, I have an altitude right here at 90 degrees. Here I have an altitude at 90 degrees. Here I have an altitude at 90 degrees. They all meet in this spot, okay? Now remember, this yellow line is equal to this yellow line, and we're also going to have a 90-degree angle here. So this altitude here in this small triangle is a perpendicular bisector in that big triangle, okay? And ditto here. So this altitude right here has a 90-degree angle here. So it's also going to make a 90-degree angle there, okay? And this side being equal to this side. So this altitude is a perpendicular bisector there, okay? And ditto with this orange altitude right here. It comes from this point there to there. I'm going to have a 90-degree angle at that altitude. And it's a perpendicular bisector on that bigger triangle as well, okay? I'll attach the Khan Academy video. It'll probably make a little bit more sense when we do that. So that we know the altitudes are perpendicular to the parallel lines that we draw. That's what I just talked about here. All right. 4 triangles are going to be congruent by little ASA because all the angles are congruent with sides in the middle. All right. Sides are all congruent by CPCTC. Okay. The parallel sides, the big lines that we draw, are bisected by the altitudes, which we kind of talked about here, yellow, yellow, yellow. Okay, altitudes in the smaller triangle are the perpendicular bisectors of the larger triangle. Okay, so you know, kind of an interesting thing there. You know, we may talk about it briefly. It may be brief on our quiz. There's really not a whole lot of math to do on that, but I think this is kind of a cool thing for us to sort of look at on 4J. Okay, that's what I got. You guys all take care. Have a good weekend and stay safe.